All right, welcome back. In our last explainer, we broke down the thread lifecycle. Today, we're taking the next step and looking at a much more flexible and honestly a more powerful way to create threads in Java.
So you probably know how to spin up a Java thread, right? But are you doing it the best way? It's super common for developers, especially when they're just starting out, to learn by extending the thread class. And hey, it works, but it can really paint you into a design corner and fast.
So let's get right into it. We're going to look at that common approach first and see exactly what kind of roadblock it throws in your way. Okay, here's the heart of the problem. Imagine your MyWorker class needs to inherit some important logic from, say, some other class. Well, you've got a big issue because Java doesn't do multiple inheritance. You're forced to choose. Do you extend thread or do you extend some other class? You can't do both. And just like that, you're locked into a really inflexible design. And this quote from the official Java docs just nails it. Think about it. Most of the time, are you trying to reinvent the very nature of a thread? No, you just want to give a thread a job to do. You're defining the task, the what, not rewriting the fundamental behavior of the worker, the how.
So, if that's the problem, what's the solution? Well, it's actually a really elegant and simple interface called Runnable.
The Runnable interface is super focused. It's designed for one thing and one thing only, to represent a task that can be executed. It's got just one method you need to worry about, run, and that's where you put all the code you want to execute on a separate thread.
I love this analogy. Think of a recipe and a chef. The runnable is the recipe, it's the set of instructions, right? The task. The thread is the chef, the actual worker that follows the recipe. And the beautiful part is, you can give that same recipe to a bunch of different chefs to work in parallel, or you can give one chef a whole stack of different recipes to work through one by one. It's that separation that's so powerful. And that brings us to the key insight. This is the big takeaway. Runnable lets you separate the task from the thread that executes it. Your task's logic is completely decoupled from the machinery of thread execution. Honestly, this is a cornerstone of good, clean concurrent design. So how do you actually use it? It's really just a few simple steps. First, you create a class that implements the runnable interface. Second, you put your task's logic inside that run method. Then you create an instance of your new runnable class, you pass that instance into a new thread objects constructor, and finally, you call start on the thread. And boom, you're off and running.
Okay, so we know what it is and how to use it, but what's really cool is how the syntax for this has evolved, making our code so much cleaner. Let's look at the old way versus the new way.
So back in the day, before Java 8, this is what you'd see everywhere. It's called an anonymous inner class. And yeah, it works, but just look at it. That's a lot of code, a lot of boilerplate, just to say, print this line. It feels so clunky, right?
But then Java 8 came along and changed the game. See, because Runnable has only one abstract method, that run method, it qualifies as something called a functional interface. And that means we can use a much better syntax.
Bam! Look at that! It's the exact same functionality, but we've boiled it all down to a single, beautiful line of code using a lambda expression. Those empty parentheses stand for the run method's arguments, which are none, and the little arrow points to the action. It's clean, it's readable, and it's absolutely the modern way to do it.
Defining tasks this way is awesome. But let's scale things up. In a real-world professional application, you're not just creating one or two threads and trying to manage a whole bunch of them manually. That's just not going to fly. It's not scalable, and it's not safe. Think about it. Manually creating and destroying a thread for every single little task is super inefficient. There's a real performance cost to spinning up a new thread. You're just burning resources, and if you're not careful, you could easily bog down your whole system, or, even worse, introduce some really nasty bugs.
And this is where Runnable really shines because it plugs right into something called the Executor Framework. This is a high-level API that basically handles all the messy thread management for you. Instead of you creating threads, you just create your runnable tasks and hand them over to an executor service. It takes care of the rest, managing a pool of worker threads to get your tasks done efficiently.
The best part is that this framework is incredibly flexible. It's not a one-size-fits-all solution. You get several different types of thread pools, each tailored for different scenarios. For example, if you need a pool with a fixed number of threads, you'd use a fixed thread pool. If you've got lots of little tasks coming and going, a cached thread pool might be better since it reuses idle threads. You get to choose the right strategy for your app, and the framework does all the heavy lifting.
Okay, let's bring this all home. We've covered a lot, but what are the key advantages? Why does all of this matter? Why is using Runnable almost always the right call?
This chart really lays it all out. When it comes to inheritance, Runnable leaves you free to extend another class, while Thread locks you in. For reusability, Runnable is the clear winner because you've separated the task from the worker. And in terms of memory, you're just way more efficient creating lightweight task objects instead of a whole new Thread subclass every time.
So, when you boil it all down, it's about writing better code. You get huge design flexibility, your code becomes way more reusable, and most importantly, it's scalable. Runnable integrates perfectly with powerful tools like the Executor Framework, which is what you'll be using in any professional-grade application. It's just the smarter way to build.
All right, so now we've got this amazing, flexible way to define our tasks and run them in parallel. That's a huge step.
But that opens up a whole new can of worms, doesn't it? Now that we can have all these tasks running at the same time, how do we stop them from tripping over each other? How do we keep them from corrupting shared data? Going back to our analogy, what happens when two chefs reach for the same salt shaker at the exact same moment? Well, that's exactly what we're going to tackle in our next explainer when we dive deep into the world of synchronization.